Hi everyone, welcome back to another unit review with PsychCasts. I'm Tony, and today we'll be reviewing the second half of Unit 1 of the AP Psychology curriculum. In this episode, we will discuss the different types of experiments, the various components that make up an experiment, common mistakes in experiments, ethics in experiments, as well as go over a little bit into the statistics involved in experiments. First, let's begin by going over the different types of experiments. The four main types of experiments are experimental, correlational, naturalistic observation, and lastly, case studies. Starting with experimental experiments. This is basically an investigation seeking to understand the relation between cause and effect. In experimental experiments, you have the independent variable and a dependent variable. Put simply, an independent variable is what you manipulate to get a change, while a dependent variable is the thing that changes when you manipulate the independent variable. For example, let's say you're trying to study the effect of a drug on sleeping insomnia by giving patients this drug and testing how fast they fall asleep. The independent variable in this case would be the drug because, well, you're manipulating it, or in other words, you're changing how much of the drug you'll be giving to the patient. On the other hand, the dependent variable in this case will be how fast the patient falls asleep, as this depends on how much drug you give to the patient. Some other things to know are control variables and confounding variables, aka the X factor. Control variables are variables that are kept constant throughout the experiment to help ensure that the results are solely caused by the experimental manipulation or the independent variable. For instance, the bed the patients sleep in should be kept constant because you don't want the bed to be a factor that can affect how fast the patient falls asleep. And if a variable was able to do that, then it would be called a confounding variable, which are often referred to as X factors, which are basically variables that might influence the result of the experiment. Going back to the example mentioned above, the bed the patients sleep in might be a confounding variable if it's different, because the different material and type of bed might influence how fast the patient falls asleep. Now, let's talk about how experimental researchers gather participants. Here, we will introduce the concept of population. Let's say you're trying to study the effect of the sleep drug on adolescents. This means that your population, which is your group of interest in the case of this experiment, would be adolescents. Now, unfortunately, you do not have enough funds to have every adolescent in the whole world to participate in your experiment. So instead, you'll be using a representative sample, which is defined as a fraction of the population that you are studying that represents the diversity of the whole population. This way, through research with only a few participants out of the whole population, you can still obtain solid research results that's generalizable to the whole population. Now, how do we obtain a representative sample? This would be done through the process of random sampling, which is when you randomly select individuals from the population to eliminate any potential bias. Now, let's go over some sampling bias that may occur. Starting with bias of selection, this is when people are selected based on the physical space they're in. For instance, let's say you were trying to survey the average time that students wake up at the high school, and you only ask the students that arrive through the front door, rather than randomly sampling students throughout the campus. The thing is, the front door might open much earlier than any other doors on campus, meaning the students that enter through those doors are probably early risers, causing your survey result to skew toward an early wake-up time for all students at the high school, when that probably isn't the case. Another sampling error is the self-selection bias. This occurs when people being studied have control over whether or not to participate. For instance, an online survey might be inaccurate because their participants are mainly highly opinionated people that are willing to complete the full survey, causing extreme survey results. Next, pre-screening or advertising bias often occurs in medical research. This is when the advertisement of the research causes skewed result. For instance, if a medical research is advertising a treatment that will stop smoking, this ad might only attract highly motivated individuals that want to quit, who of course might quit regardless of the treatment. Another one would be healthy user bias, is when basically the study population tends to be in a better shape than the general population. Now, let's go back to gathering your participants. Once you've got a representative sample, you will now randomly assign them into either the experimental or the control group. You can think of the experimental group as the group that receives the independent variable, or of course in this case the sleep drug, and the control group as a group that does not receive anything, or in this example receives a placebo drug, which is essentially a seemingly therapeutic object or procedure, but actually have no effect. The main purpose for the control group is for comparison with the experimental group to determine whether the independent variable actually had an effect. Going back to random assignment, the easiest way to choose which participant would be assigned to which group is to draw from a hat. Another thing is that sometimes the participants and the researchers may skew the result of our research. To prevent this, researchers may use a single or double blind design. A single blind design basically means that the subject does not know whether they are in the experimental or the control group. A double blind design means that both the subject and the researchers don't know who's in the experimental and who's in the control group. Now, let's talk about correlational research. In this type of research, you're not trying to find a cause and effect. Rather, you're trying to find a correlation, or basically the association between two or more variables. In this type of research, the researchers will simply observe but not manipulate any other variables. There are mainly three types of results that you need to know for this type of research: positive, negative, and no correlation. Positive correlation means that as one variable increases, another variable increases as well, meaning that they have a direct relationship. When looking at a graph, positive correlation will have a line that is going to the top right corner. On the other hand, a negative correlation basically means that as one variable increases, the other variable decreases, meaning they have an indirect relationship. On a graph, you should see a line that is going down toward the bottom right corner. Lastly, no correlation simply means that there is no association between the variable at hand. So on the graph, there wouldn't really be a line and the points would be scattered randomly. On a correlation graph, you'll often see a number ranging from +1 to -1. This is known as the correlation coefficient. When a coefficient is positive, that means a positive correlation. And basically when it's negative, it will mean that it's a negative coefficient. When the coefficient is 0, that means there's no association. Remember, the higher the value of the coefficient, or actually the absolute value of the coefficient, the stronger the correlation, whether that is negative or a positive number. For example, a 0.1 correlation is actually weaker than a negative 0.99 correlation. A key thing to remember, and this is something that definitely would come up on the AP exam, is that correlation does not mean causation. Just because the students with less sleep gets higher test scores doesn't mean that sleeping less make you smarter. Rather, this is simply an association between two variables. Now, let's bring back the concept of confounding variables to correlational research. Students that sleep less may be spending more time studying, thereby earning a higher test score. So the amount of time a student spends studying could be a confounding variable in the research. I would also like to bring up two specific types of research that can be set up as either correlational or experimental research. First is longitudinal studies, which are studies that happen over a long period of time with the same participants, hence the name longitudinal. Second, cross-sectional studies are basically studies designed to test a wide range of subjects from all different situations and backgrounds to increase generalizability. Here are some more vocabs for experimental design. Starting with operational definition, this is basically the way in which specific variables of an experiment will be measured. For instance, going back to the sleep drug research, researchers would have to define the operational definitions for how to measure how long it takes the patient to fall asleep. Would they use a timer? Would they look at the patient's heart rate, etc.? Internal validity is basically the certainty with which the result of an experiment can be attributed to the manipulation of the independent variable rather than some other confounding variable as described above. External validity is the extent to which the finding of the study can be generalized to other contexts of the real world. Another important concept is reliability, which is whether or not the same result appear if the experiment is repeated under similar conditions. On that note, a similar concept, inter-rater reliability, is the degree to which different raters agree on their observations of the same data. Now, the last type of experiment is naturalistic observations, which is when researchers simply observe and study behaviors outside of the lab. For instance, researchers observing the behaviors of a wildlife coyote might be a naturalistic observation. Let's go over some basic statistics mentioned in AP Psychology, starting with descriptive statistics, which basically summarizes the data, and on the other hand, inferential statistics, which allow researchers to test hypotheses about the data and determine how confident they can be in their inferences about the data. Some common examples of descriptive statistics are the mean, the mode, and the median. The mean is basically the average of a set of numbers, while the mode is the most frequent occurring number in a set, and the median is the number that falls in the middle of the distribution of the numbers. Yeah, and before I forget, the range is the largest number minus the smallest number, or basically the maximum minus the minimum. You can represent these statistics through a normal curve, which is also referred to as a bell curve because of its shape. Moving on, standard deviation is the measurement of the average deviations of numbers from the mean. When you have a high standard deviations, that means the numbers are kind of all over the place. This results in a bell curve that is really wide and short. On the other hand, when you have a low standard deviation, that basically means the number don't differ too much from the mean, resulting in a graph that is tall and narrow. Also, on a standard deviation curve, the mean would be on the center of the graph. Now, here's the sucky part about these standard deviation graphs. You're going to have to remember the percentage of scores with their respective deviations from the mean. For instance, about 68% of the score are one less or one more than the mean. And then about 95% of all scores are within 2 standard deviations above or below the mean. And about 99.7% of all scores are within 3 standard deviations above or below the mean. Let's move on to another concept tested on the exam, which is called percentile. This statistic is often used on reporting scores on standardized testings and represent the standing of one scores relative to all other scores. For example, scoring in the 99th percentile means that your score was better than 99% of other test takers. Moving on to skewed distribution, this is basically when the center of the curve either tilts toward the left or to the right, rather than staying in the middle. In this case, the median would be a better indication of central tendency than your mean, since the mean is non-resistant to skewness. In a positively skewed graph, the curve tilts toward the left, meaning that most value are on the lower end, but there are a few exceptionally high values on the right-hand side. On the other hand, a negatively skewed graph means that the center tilts toward the right, and that most values are on the higher end, but there are also a few exceptionally low values on the left-hand side. Moving on to inferential statistics, this includes sample size, which is the number of individuals measured. Remember, the larger the sample size, the more reliable the experiment is. Now, let's discuss some vocabulary with inferential statistics, starting off with the null hypothesis, which basically states that a treatment has no effect in an experiment, while the alternative hypothesis is basically stating that the treatment does have an effect. There are 2 types of error that can occur with testing a hypothesis. One, a type 1 error, is basically when you think that a difference exists when in reality a difference does not. This is often referred to as a false positive. A type 2 error refers to when you think a difference does not exist, but in fact it actually does. This can be referred to as a false negative. And the probability of making a type 1 error is called the p-value. If the p-value is 0.05, then we have about a 5% chance of making a type 1 error. Now we've come to the last part of this episode, ethics in research, which is also really crucial on the exam. To ensure proper treatment of animals and human subjects in the research, the Institutional Review Boards, or the IBS, assesses research plans before the research is approved. Additionally, researchers should give participants informed consent, which is when the participants give their consent to participate in the study after they have been told about the research's detail. Participants must also be able to leave the experiment anytime they wish, and after the experiment, participants must also receive a debriefing, which is when they are told the exact purpose of their participation in the research and any deceptions that may be used during the experiment. And another very important ethicality is confidentiality, which is when the data collected from the participants remain anonymous, meaning that their name or any personal data will not be disclosed. Well, That's it for the second part of the Unit 1 of the AP Psychology curriculum. Hope this episode was somewhat helpful for you guys, and please tune in for our next unit review on both YouTube and other podcasting platform. If you're on YouTube, please like the video and subscribe to our channel and comment down below what unit you guys want us to do next. Thank you so much for listening and have a wonderful day.